my name's Matt Hamilton. I'm a developer advocate at Protocol Labs, working on Filecoin. And this is a talk about developer struggles and pain points. This is your second dose of Matt today after the first dose you had to start with. And what is actually interesting is I could probably sum up a lot of this by just saying what he said. What is good is that we didn't collaborate at all on either of our presentations, and they do actually line up fairly well, which is quite good. So, because I'm coming at this from these are the things that developers tell me point of view, and the other Matt was talking about, okay, this is the kind of stuff that we sort of need to solve from their point. So, really, this comes down to sort of expectations versus reality. And I asked ChatGPT to create a nice comic of what it's like at some of the conferences in which I get asked questions by developers. This came out probably a little more accurate than I ever would have imagined, actually. If anybody has been on a booth at one of the conferences, one of the Filecoin booths, and the general chaos and confusion sometimes around what Filecoin's offering actually is. And so developers come up, we're typically at an event like this. We're at ETH Denver. It's an Ethereum event. It's a blockchain event. It's a cryptocurrency event. People come up. Filecoin is a file storage network. They've typically heard of Filecoin. The name is relatively self-explanatory, that it is to do with files, it is to do with data. Often they have some experience of IPFS already. Typically they have more knowledge or experience of IPFS than they do a Filecoin. So their thought is, okay, Filecoin is a file storage network. We now have FVM and FEVM, the Filecoin Ethereum virtual machine, that allows you to run smart contracts written in Solidity directly on the Filecoin Layer 1 network. So the immediate assumption, which is a totally reasonable and understandable and expected assumption and conclusion, is that you should be able to access those files. You should be able to store and retrieve data from smart contracts on the Filecoin network, right? Filecoin stores data. You're running smart contracts on the Filecoin network. Surely you should be able to access data from the Filecoin network. Unfortunately, you can't, right? And that is just a big mismatch between expectations of what people are expecting to be able to do. And this comes around actually for some very good reasons, right? There's very good reasons why you can't do this, both from a architectural and historical view as to how we've got here, but also from a point of view of actually really what it is you're actually trying to do, right? So a lot of this comes down to a mismatch of the characteristics between Filecoin and between smart contracts. And like I said, this actually ties up very well with a very similar table that other Matt had up earlier about data availability versus data storage. So like I said, what's quite nice is that actually these two things seem to actually mesh fairly well. So hopefully the sticking points that developers have had, that we have experienced, hopefully this sort of shows that we do seem to be hopefully getting in that direction of solving them. So Filecoin, designed to store gigabytes, petabytes of data, large-scale data. Storage and retrieval is measured generally in hours, if not days, for storing data, right? If data is stored in a sealed sector, sealing a sector takes in the orders of magnitude of hours, 4 hours, I think it is. There's optimizations that have been done for that sort of thing. But, we're not talking about the time that you could retrieve within block times. So if we're just talking about Avail DA, they're talking about 20-second block times. The Filecoin network has 30-second block times. So, smart contracts are designed to work with kilobytes of data or even bytes of data. So as was pointed out, somebody said earlier, all layer 1 blockchains are data availability solutions. All layer 1 blockchains allow you to store data. Yes, they do, but typically very small amounts of data because it's stored in the blockchain state that is replicated across all nodes and has to be dealt with in the orders of magnitude of, a block time. So, like I said, 30-second block time for Filecoin, which is actually relatively slow in terms of a lot of modern blockchains nowadays. A lot of them are in the single second range here. So, this is where we get this issue here, is that we've got this mismatch of characteristics, that Filecoin is storing the data off-chain because it's very large amounts of data, whereas smart contracts are looking to access data on-chain. So how do you move that data from one to another? So, the breaking down the problems developers face. So storing small data. Typically, they will have a small amount of data they want to store. Say you're dealing with something like NFTs, you've got your little 50 kilobyte monkey JPEG. How do you store that in Filecoin? Trying to just store it natively is not going to work. Storage providers are used to dealing with 32 or sometimes 64 gigabyte sectors. That is what they are incentivized to store, and the cost is linear. The cost is fixed. So the cost to store a 32 gigabyte sector for a storage provider is going to be the same whether it's got useful data or random data or no data in. Yet they're being paid. Their revenue is dependent upon people paying to store that data. So they're going to want to try and fill those sectors as much as possible. So they're not going to be interested in just your little 50 kilobyte monkey JPEG. So that's where the likes of aggregators come in. So we have things like Web3 storage, NFT storage, Lighthouse. We've had several in the past as well that have tried to aggregate this data together. So getting all of this small bits of data, putting them all together, and then storing them. Now, that introduces its own problems because the data needs to be aggregated. So the storage aggregators need to wait until they have a certain amount of data collected together that they can batch up into a single storage deal to make with a storage client. And each one of these aggregators is doing that themselves independently. So Web3 storage is aggregating data, NFT storage is aggregating data, Lighthouse is aggregating data. So there's almost like this problem of, for want of a better word, data liquidity there, and that they're all waiting until they get enough data. But that's not a kind of a shared pool that they're all working within. And then in terms of retrievability, so a lot of these services, I think all of them actually, also pin data to IPFS so that you can access it back again. But for a lot of these cases, if they're already storing the data on IPFS, what value is it that data is stored on Filecoin? And again, going back to the questions about data availability, a lot of the times you don't need the data beyond a certain time frame, right? The data is changing, or the data only needs to be kept around for a certain period of time for it to be validated and kept as a backup in case there's a dispute or whatever it might be. So really, is there a point in taking that data anyway and putting it on Filecoin for it to be stored, for whatever it might be, 6 months, 18 months on the Filecoin network, if you only need it for a short period of time? And one of the areas that's kind of lacking is the ability to be able to, for a developer to be able to specify that amount of time that they want the data to be stored. If you're making a deal on Filecoin, you can say, you can choose your deal length, but that's still a large, that's still a long period of time. You're talking 6 months to sort of 18 months for a storage deal. What if I just want the data to be around for a day? Immediate retrievability. So how do you ensure that you can get the data back in a timely manner? So the storage providers, they will store the data, but there isn't really a guarantee that they're going to be able to serve the data back up. Yes, we have some initiatives to try to measure that and to, talks about how we can incentivize that retrieval side of things. The big thing to bear in mind is that storage is a fairly bounded amount of cost, right? If I want to store 1 gigabyte of data, that's going to take 1 gigabyte of bandwidth and 1 gigabyte of disk to store that data, right? And I know how long, because of the deal, I know how long it's going to be stored for, so I can sort of plan in advance. But retrieval is unbounded. How many times is that data going to be retrieved? Is it going to be retrieved once in that time? Is it going to be retrieved once a second for the duration of that? So, that might incur large amounts of bandwidth costs for a storage provider. So that's one of the areas why retrieval is actually a little bit tricky, because we have to kind of deal with that. And as said, blockchains move at a very regular rate. So the Filecoin chain, every 30 seconds there's a new block. So if you need to retrieve that data, you need to retrieve it within the time frame that the blockchain can handle. And this was mentioned just earlier with Avail as well, and by Matt talking about data availability. So that's something that needs to be considered. Has the storage provider sealed the copy? As I mentioned before, sealing and unsealing is a process that's measured typically in hours, not in seconds. What is their retrieval policy? Are they going to allow you to fetch that data? And depending upon the blockchain and how things are arranged, so typically within a blockchain, each node executes everything, the same transaction, and then they all compare to make sure that there's consensus. But if you've got 1,000 nodes on the network, does that mean there's going to be 1,000 requests for that data from wherever it is stored all at the same time? And that could come around with some very interesting usage patterns, because suddenly you've got this pattern where you suddenly get these big bursts of traffic coming in, potentially, depending on how it's architected. Aggregations and aggregation pipelines. Like I said, when I store data as a Web3 developer, I store the data. It might not make it to Filecoin until it's been aggregated, until a deal is made, until the storage provider has accepted that deal. Storage providers have to make deals, have to have relationships. Aggregators have to have relationships with storage providers, because a storage provider is not necessarily going to accept data from anybody randomly on the network. And this, again, is one of these areas where we get this mismatch of expectations, right? We're here at a blockchain conference, Filecoin, it's a big decentralized network. It's permissionless to a degree, right? You need a storage provider to accept a storage deal. And the reality is, if you're a storage provider in the US, you go and talk to somebody like Picnic in Las Vegas, they're a registered company in the US. They are legally not allowed to do business with, say, the OFAC, naughty list, so to speak. So North Korea, for example, right? So they can't accept a storage deal from an entity that may jeopardize them in a regulatory sense. So they're going to have to do some sort of level of KYC. So you end up with this process where the SP has done some sort of level of KYC on the aggregator. The aggregator then requires you to create an account. So if you go to Web3 storage, you've got to create an account before you can store data. If you go to Lighthouse, you've got to log in with your GitHub credentials or create an account or whatever it is in order to do it. And that's so that they've got some kind of trace that they can come back and say, okay, we're no longer going to accept data from this particular person. Then there's the question of how do you get your data back? So my 50 kilobyte monkey JPEG is gone, through this aggregator. It's ended up in a storage deal. It's now part of a big chunk of data that might be, 10 gigabytes, 32 gigabytes in size. How do I get that back? How, from a smart contract, can I prove that that data has been stored? Now, we've come up with various standards. There's a standard called PODSI, Proof of Data Sector Inclusion, that allows me to prove that this one little 50 kilobyte chunk of data is actually contained within this 32 gigabyte chunk. But how well does that actually scale, right? We've never, I don't think, really proven that case. I mean, think about how many chunks of 50 kilobytes could fit within a 32 gigabyte sector. I'm not going to try and do the maths in my head. It's a large number, though. And if you think about, so the way that PODSI works is it's the sort of Merkle tree proof. And so if you have a large number of elements stored within that sector, that's a pretty large tree, right? Now, it's not linear in terms of the size, but it's still going to get pretty big. And it might be that in order to prove something, you've got to submit to a smart contract this block of proof data that might be, a megabyte in size. Well, is your smart contract going to be able to process that? What are the costs? What are the gas costs you're going to pay to process that? And then finally, the actual processing of the data. So blockchains have limited processing capabilities. And this kind of goes back a little bit to expectations. And somebody thinks, okay, so I've got a smart contract, I've got data, that means I can do processing of that data within the smart contract. And when you actually look at it, well, the cost of doing data processing on a blockchain is expensive because every node is processing it. So you've got a gas cost related to the amount of storage space, like memory space your contract is using, the amount of compute cycles it's going to use. So even if you could get that data into a smart contract, you're not going to want to be taking large chunks of data into a smart contract to process them on-chain. You're going to want to do that off-chain. And a lot of the languages just don't have the capabilities to deal with it. So Solidity, for example, has no string processing capabilities. So one example might be, okay, from within my smart contract, I could fetch a block of JSON that is the metadata for an NFT, and I want to do some sort of logic that says, okay, any NFT that has this particular characteristic that is described within this block of JSON, I want to allow, some gate, I'm doing token gating or something, and I want to allow the smart contract to allow somebody to perform some operation based upon whether a value is within some JSON, right? Now, in something like JavaScript or Python, you will have a JSON parser library that's available. You could probably do that in one line of code. You don't have that in Solidity. There aren't the libraries to do that. There isn't even the kind of like string find, string compare type libraries within JSON. So trying to process something like, a block of JSON data within Solidity is actually, near impossible in any practical sense, right? So, what would you do? I mean, somebody once suggested and said, okay, well, you could do some machine learning inference within a smart contract, even if you just took, the top layer of a neural network, the values, and put them in there. Solidity doesn't have floating point operations. It's only, it's only integers, right? So even something like that's not really possible. So the chances are you're going to do that all off-chain anyway, and you're going to use a decentralized compute network like Bacalhau to do that. So in that case, why get the data on-chain anyway? Does your smart contract actually need to access that data? And like I said, it comes down to sort of expectations, and a lot of what some of the developers want to do and think they want to do, when you actually talk to them, there's actually better ways to solve that. Maybe they don't actually need it on-chain. What they need is some sort of proof that that computation has happened, or that transformation or whatever off-chain has happened. They want that on-chain. And, there's projects like Fluence, there's projects like Co-op Hive, Lilypad, etc., that are enabling that kind of integration. But typically it may be that you want to do that processing off-chain. If you do, then how do you ensure the integrity of that? Do you then need some kind of consensus process amongst that data and say, okay, we're going to transform it on a dozen different nodes and then compare it and check that it's all valid, et cetera, et cetera, et cetera. So there's a lot of elements there. So I think that probably so that sort of sums up a lot of the problems that Web3 developers, dApp developers see. We've got a workshop in a little bit that Hannah's going to be running, in which hopefully we can dive into these and talk a little bit more about it, and hopefully bring some of the material that Other Matt was talking about earlier on with data availability, and see how some of those things can map into some of these requirements that developers have and some of the problems they're seeing. So that's all I've got. I don't know if there's any questions around any of this. Like I said, we can dive into it more. Yeah, Laura.
You said something like Bubbles tap that you said.
Yes.
I'm sorry. And it was saying these two, we are moving that.
Right. Yes, that's the paradox. There are certain circumstances which they do need it. They definitely do need it. And if you look at things like AveilDA, they're solving a very specific problem of layer 2 rollups and getting that data in. That's like a very specific problem. There are, I think, valid use cases in which you do want that data on-chain. You do want to be able to get to that, definitely. But again, I think it just reinforces the mismatch of expectations and the mismatch of messaging maybe around this. And maybe that's possibly what we need to somehow, for a better word, fix, is this expectation when somebody comes up that in an event like this, that they believe that what they should be able to do is access all of that data on Filecoin if they store it on there, from a smart contract. Right. Yeah, exactly. Yeah, work on what are those good synergies? What is it good for? What is it not good for? It's like Filecoin is fantastic for long-term archival stuff. That's generally not what people are doing here per se. Then there's the whole like DeFi side, which are totally separate side, like DeFi around storage deals, the like lending, the stuff that Glyph do, for example, around lending. There's that whole separate side there around the marketplace that effectively Filecoin creates, that you can then use within things like DeFi, which is a whole separate area there, which maybe people don't necessarily appreciate again, and that's something we maybe need to get better at explaining and getting in front of them to start with. Any other questions? No? Good. Okay, like I said, we've got a workshop later on that Hannah's going to be leading in half an hour, something. Oh, it's an hour. Oh, yes, because somebody is no-show. Okay, great. We can roll straight into that then. So I'll pass over to Hannah.